Hello, my name is Yossaphan Kaenwong. My student ID is 65364084. So we will introduce transport layer. So in the objective, we introduce general service we normally require from the transport layer, and we discuss general transport layer protocols. We discuss UDP, which is the simpler of two protocols. We discuss TCP service and feature, and show how TCP provides a connection-oriented service using a transition diagram. So in introduction, the transport layer provides a process-to-process communication. So the communication is provided using a logical connection. So in this picture, is the transport layer is communication by logical connection. Transport layer service. The transport layer is located between the network layer and application layer. The transport layer is responsible for providing service to application layer. And this is a picture of network layer versus transport layer. The first duty, process-to-process communication. The process is the application layer entity, and the network layer is computer level, is host-to-host communication. And this is the picture of port number. By in addressing is a port number. A local host and remote host is IP addresses. The processes is port number. The client program, the ephemeral port number short-lived, and the universal port number for server well-known port number. Example, the daytime client process is 52,000. The daytime server process is 13. IP address versus port number. IP address and port number is different roles in selecting the final destination of data. The destination IP address, the host among the different hosts in the world, the port number one of the processed on this particular host. ICANN and range. Internet Corporation for assign name and number. Well-known ports assigned and controlled by ICANN. Registered ports is registered with ICANN to prevent duplication, and the dynamic port is neither controlled nor registered, used as temporary or private. So in example 3.1 in Unix, the well-known ports are stored by in the file called /etc/service. We can use the grep utility to extract the line corresponding to the desired application, and SNMP use two port number each for a different purpose. So this is a picture to link a socket address. A pair of socket addresses is the client socket address and the server socket address. Encapsulation and decapsulation. The package at the transport layer in the Internet is user datagrams / segments / package. We prefer to transport layer payloads and packets. Multiplexing and demultiplexing. Multiplexing is the many-to-one. So this is an entity accepts item from more than one source. And demultiplexing is one-to-many. So it's an entity deliver item to more than one source. Pushing and pulling. So by flow control is balance between production and consumption rates. Pushing is the sender delivers items without a prior request from a consumer, and pulling is the producer delivers the item after the consumer and requests them. Flow control at the transport layer. The sending process is the producer. The sending transport layer is the consumer and a producer. A receiving transport layer is the consumer and producer, and the receiving process is the consumer. So in example 3.2, the above discussion requires that the consumers communicate with the producer on two occasions, when the buffer is full and when they are vacant. If the two parties use a buffer with only one slot, the communication can be easier as soon as that each transport layer uses one single memory location to hold a packet. When this single slot in the sending transport layer is empty, the sending transport layer sends a node to the application header to send its next chunk. When its single slot in the receiving transport layer is empty, it sends an acknowledgement to the sending transport layer to send its next package. As we will see later, however, this type of flow control using a single slot buffer at the sender and the receiver is inefficient. So the error control at the transport layer is the sending and the receiving transport layer. The receiving transport layer manages error control by informing the sending transport layer about the problems. So in the sequence number 2 power m is the packet are numbers. The sending transport layer which packet is to be resent, and the receiving transport layer which packet is duplicated or which packet has arrived out of the order. Acknowledgement positive signals. The receiver can discard or corrupt package and duplicate packets. The sender can detect lost packets and resend the package out of other package, either discard or store until the missing ones arrive. And this is a picture of sliding window in circular format. In example is 4 packets have been sent, have the sequence number of first outstanding packet, and number 4 is sequence number of next packet to send. And this is a sliding window is in linear format. Combination of flow and error control. Flow control, the use of two buffers. Error control is the use of sequence and acknowledgement numbers. Two requirements combined by two number the buffers. Congestion control, router and switch buffers. The mechanism and technical can control the congestion and keep the load below the capacity. And this is a picture of connectionless service. So we will see the message 1 is communication to message 1 in another, but the message 2 is deliver out of the order. Connection oriented service. Dependency between packets for control, error control, congestion control. It's like a last picture. Connectionless and connecting oriented service represent as FSM. So it's like this picture. Transport layer protocols. We can create a transport layer protocol by combining a set of services described in the previous section to better understand the behavior of these protocols. We start with the simplest one and gradually add more complexity. Our first protocol is a simple connectionless protocol with neither fault nor error control. We assume that the receiver can immediately handle any packet it receives. So this is a picture of simple protocol, and this is a picture of FSMs for the simple protocol. So in example 3.3 is show an example of communication using this protocol. It is very simple to send packets one after another without even thinking about the receiver, like this picture. So the stop and wait protocol or second protocol is a connection-oriented protocol called the stop and wait protocol, which use both flow and error control. Both the sender and the receiver use a sliding window of size 1. The sender sends one packet at a time and wait for an acknowledgement before sending a next one. To detect corrupt packets, we need to add a checksum to each data packet when a packet arrives at the receiver side. Sequence numbers, acknowledgement numbers, FSMS is have a sender and the receiver efficiency preparing. So in this picture is the stop and wait protocol. So in the stop and wait protocol, an acknowledgement number always announces in modulo through arithmetic the sequence number of the next packet expect. And this is a FSM for the stop and wait protocol. In example 3.4 is show an example of the stop and wait protocol. Packet 0 is sent and acknowledged. Packet 1 is lost and resent after the timeout. The resent packet 1 is acknowledged and the timer stops. Packet 1 is sent and acknowledged, but the acknowledgement is lost. The sender has no idea if the packet or the acknowledgement is lost. So after the timeout, it resends packet 0 which is acknowledged by this picture. So go back in protocol. To improve the efficiency of transmission, multiple packets must be in transition while the sender is waiting for acknowledgement. In this section, we discuss one protocol that can achieve this goal. In the next section, we discuss a second. The first is called go back in. So it's the rationale of the name will become clear later. So continue is sequence number, acknowledgement numbers, send window, receive window, timers, resending packets, FSMs, send window size, and go back in versus stop and wait. So in this picture, we will is the go back in protocol. So we can send several packets before receiving acknowledgements, but the receiver can only buffer one packet. We keep a copy of the sent packet until the acknowledgements arrive. And in the go back end protocol, the acknowledgement number is cumulative and defines the sequence number of the next packet expect to arrive. The send window is an imaginary box covering the sequence number of the data packets that can be in transit or can be sent. The maximum size of the window is 2 power m minus 1. And the send window is an abstract concept defining an imaginary box of maximum size of the window to power m-1 with 3 variables. So it's SF, SN, and S size. So this picture is the sliding the same window. The same window can slide one more slot when an error-free ACK with ACK no greater than or equal SF and less than SN in modular arithmetic life. So the receive window for go back in. The receiver window is an abstract concept defining the imaginary box of size 1 with one signal variable Rn. The window slide when a correct package has arrived, sliding occur one slot at a time. Timer resent all outstanding packets when this timer expires. Resending packet once time out the machine goes back in location and resends all packets. So the picture is the FSM for the go back in protocol. And this picture is the send window size for go back in. In the go back in protocol, the size of the send window must be less than 2 power m. The size of the receive window is always 1. Selective repeat protocol. The go back in protocol simplifies the process at the receiver. The receiver keeps track of only one variable, and there is no need to buffer out of other packets. And this is a picture of outline of selective repeat. This is a picture of send window of selective repeat protocol. And this is the selective repeat window size. So the A is a picture send and receive window of size is 2 power m-1, and B is the send and receive window of size more than 2 power m-1. Bidirectional protocols. The 4 protocols we discussed earlier in this section are all unidirectional data packets flow in only one direction and acknowledgements travel in the other direction. In real life, data packets are normally flowing in both directions, from client to server and from server to client. So this is the design of piggybacking in go back in. The Internet Transport Layer Protocol. An Internet is the interconnection of a set of devices capable of communication. In this definition, a device can be a host such as a large computer, desktop, laptop, workstation, cellular phone, or security system. A device in this definition can also be a connecting device such as a router or switch, a modem that changes the form of data, and so on. And this is a picture of position of transport layer protocol in TCP/IP protocol suite. And this is a table of some well-known ports used with UDP and TCP. So in summary, the main duty of a transport layer protocol is to provide process-to-process communication. To define the processes, we need port numbers. The client program defines itself with an ephemeral port number. The server defines itself with a well-known port number to send a message from one process to another. The transport layer protocol encapsulates and decapsulates message flow control balance of exchange of data items between a producer and a consumer. A transport layer protocol can provide 2 types of service: connection-less and connection-oriented. In a connection-less service, the sender sends packets to the receiver without any connection establishment. In a connection-oriented service, the client and the server first need to establish a connection between themselves. And we have discussed several common transport layer protocols. In this chapter, the stop and wait protocol provides both flow and error control, but in efficient, the go back in protocol is the more efficient version of the stop and wait protocol and takes advantage of preparing the selective repeat protocol. A modification of the go back in protocol is better suited to handle packet loss. All of this protocol can be implemented bidirectionally using piggybacking. Thank you.